Problem 64. How many grams of solutes are contained in each solution in problem 62? So here's problem 62. So you're given 3 solutions, and we need to know how many grams of the solutes are in each of these solutions. So the first one is 250 milliliters of 0.55 molarity sodium nitrate. Now remember, molarity is moles per liter. Moles per liter. And the way you should interpret 0.55 m, or 0.55 molarity, is for every 1 liter of solution, there is 0.55 moles. The problem is asking us for grams. Remember, we're doing 64. How many grams are in there? So if we know the volume, then we can use the concentration, the molarity, to get from volume to moles, but we need the molar mass in order to get from moles to grams. Now, 1 mole of sodium nitrate is 89.994 grams. And the way we got that, we add the atomic masses of sodium, nitrogen, and oxygen, multiplying them by their respective numbers. You got 3 oxygens, so its atomic mass is multiplied by 3, and then everybody else by 1. And adding it all up, you get 84.994. So 1 mole of sodium nitrate is 89.994 grams. And we're dealing with milliliters of solution, so we put it all together like this. We start with milliliters of solution, and using the milliliters to liters conversion first, and then we go from liters to moles using the molarity, and then finally moles to grams using the molar mass. So these 3 relations are used to build the 3 conversion factors. We start with 250 milliliters, get from milliliters to liters, get from liters to moles, moles to grams, all the units cancel, you're left with grams, and the calculation gives you 12.374 grams sodium nitrate, which rounds to 12 grams sodium nitrate. The next one, we got 145 milliliters of 4 molarity nitric acid, HNO3. This is a similar problem as the last one. We're given the volume in milliliters and the concentration in molarity. So again, we're going to need the molar mass. So finding the molar mass, you got 1 hydrogen, 1 nitrogen, 3 oxygens, and multiplying the atomic masses by the numbers of atoms and adding it all up, you get 63.012. So 1 mole is 63.012 grams, and we know the concentration is 4 molarity, so 1 liter of solution contains 4 moles, and then finally 1,000 milliliters in a liter. So starting with 145 milliliters, you get to liters, and again get from liters to moles using the concentration, and then from moles to grams using the molar mass. Units cancel, you got grams at the end, and the numbers calculate to give you 36.546 grams, which rounds to 37 grams nitric acid. The last one is actually a little simpler. You got the volume is already given to you in liters, and the concentration is in molarity again. And the formula is a little simpler too, HCl. So HCl, you got 1 of each. So adding up the atomic masses gives you 36.461 grams per mole. So 1 mole contains 36.461 grams of HCl, and 1 liter contains 2.5 moles because it's 2.5 molarity. So starting with the 6.5 liters, get from liters to moles using the concentration, and then from moles to grams using the molar mass. And the units end up giving you grams, and the calculation gives you 592.49, which rounds to 590 grams of HCl.